Example 4. This is a 2008 AP exam question, and it says, consider the differential equation dy by dx equals y minus 1 over x squared, where x is not equal to 0. So at x equals 0, looks like there's going to be divide by 0, which is going to give us vertical tangent or an asymptote. Part A says, sketch a slope field for the given differential equation at the point indicated. So on those black dots, we want to draw slope segments, and we're going to plug in the x and y coordinates for those black dots to be able to calculate slope segments. So I'm going to start with y equals 1, because at y equals 1, the numerator is going to be 0, and 0 divided by anything is going to give us 0. So we have horizontal tangents at y equals 1. And then going to y equals 2, we're going to end up with 2 minus 1 in the numerator. So 1, we're going to end up with 1 in the numerator. And so when y is equal to negative 1, we're going to divide by 1. So we're going to end up with slope of 1. And at x equals 1, y equals 2, we're going to have slope of 1 again. And at x equals 2, y equals 2, we're going to end up with 1 divided by 4, which is going to be 1/4. So we have positive 1/4 as my slope through here. And then at y equals 0, the numerator is going to be negative 1. So it's pretty much going to be the same as at y equals 2, except negative. So we're going to get negative 1 divided by 1, which is a slope of negative 1. At x equals 1, y equals 0, we get negative 1 divided by 1, so we get a slope of negative 1. And at x equals 2, y equals 0, we get negative 1 divided by 4, so we're going to end up with a negative 1 over 4 slope, so something like that. Part B says, find the particular solution of y equals f of x, a differential equation with initial condition 2, 0. So it's going to pass through this point. So the solution we're going to find is the equation that passes through that point. So to solve the differential equation, we're going to separate our y's with dy's algebraically and our x's with dx's algebraically. And then we're going to use that initial condition of 2, 0 to solve for the plus c. So my first step is we're going to separate. So I end up with dy over y minus 1. I'm going to end up with, on the right-hand side, dx over x squared. Once I've separated my y's with dy's, x's with dx's, I can now integrate both sides. And when I integrate dy over y minus 1, I have to recognize that is a special case log. So I have my log function, so it's going to get log y minus 1. And that's going to be equal to the 1 over x squared is a power rule. X to the power of negative 2 becomes x to the power of negative 1. So it's going to be 1 in the denominator, x in the denominator. And because it's a negative power, I have to use chain rule, and I'm going to end up with negative. So I get negative 1 over x. Don't forget the plus c, which we're going to solve for. So before I solve for plus c, I'm going to put it into its exponential form, y minus 1. And we end up with e to the negative 1 over x plus c. Okay, and that plus c is going to become a coefficient. So I'm actually going to put that in the coefficient part of it. So y minus 1 is equal to, I'm going to rewrite this as e to the c, and then times e to the 1 over x. Now there's a little bit of a concern if we solve for the plus c in this step here, because if we plug in y equals 0, we get a negative inside the log, and that could be a bit of a problem. So it's probably better to solve for the plus c in its exponential form. Okay, so at this point, I'm going to plug in my y value, x and y values. So y equals 0. So y equals 0. I'm going to plug that in. Minus 1. That's equal to the e to the c, which I'm solving for, and times e to the 1 over x, so 1 e to the 1/2. Okay, so that's going to be, sorry, negative 1/2. Okay, so solving for c, e to the c, I get negative 1 is equal to e to the c over the square root of e. And then just going to cross multiply this, solve for e to the c. That's what I'm solving for here. Just change that to blue. And so I get e to the c is equal to negative square root e. Okay, so there is our c value, that was our constant that we solve for. So my equation now is going to look like this. Y equals e to the, so negative root e times e to the negative 1 over x, and then the minus 1 on the left-hand side becomes a plus 1 on the right-hand side. So this represents the solution to the differential equation that passes through that particular point. For part C, we're asked to find the limit of this function as x goes to 0. So I'm going to rewrite this as a limit. So the limit as x approaches infinity, and this is going to be negative root e times e to the negative 1 over x, okay, plus 1. Okay, so when I can just plug infinity into here, and so I get negative root e times e to the 1 divided by infinity is 0, so we get e to the 0 plus 1. So my limit is 1 minus the square root of e. Okay, so if we take a look at our differential equation, this is approximately equal to 0.648, so 0.6487, so I'm going to round that to 9. Okay, so we can kind of estimate that's about, in this position here, about 0.65 on the axes. And you can see that as we draw, so I'm sketching my horizontal asymptote somewhere around here. Okay, so as we draw this graph, okay, follow the slope lines, we can see that it's going to follow these slope lines in this direction here, and then it's going to follow the slope lines. It looks like it's kind of following these slope lines here. Let me just redo this one. So it looks like it's following these slope lines and kind of going into that spot there. Okay, so it's going to look like this, but the horizontal asymptote to infinity looks like it's going to be at about 0.65, somewhere around there. And that looks like that's the case if I follow these slope field lines. Now, when I actually draw this graph, okay, if I actually drew this graph on Desmos, okay, you can see that there is another part of this graph, and I indicated before that there was a vertical asymptote, look like through 0, because that's when we're going to divide by 0. And in fact, there is a horizontal, so there is a vertical asymptote there. If you kind of follow these slope lines, the graph's going to kind of dive down towards that axis there.